So what is up everyone, and today I'm going to try to solve a problem that is involves with derivatives, and to be exact, we're going to try a problem that involves in derivatives of trigonometric functions. And before we start, I'm gonna flash the rules that we must follow in solving derivatives of trigonometric functions. So let's start. So after we've learned or we've known the rules or step how to solve derivative of trigonometric function, now we can start to solve the problem. So first, we have here y. Oh wait, okay, is equals to y is equals to x squared, or x raised to 2 cos open parenthesis x over 2. So we're gonna solve this involving with trigonometric, as I said earlier. So this involves with a product rule, and let's start to try to solve it. So our derivative for y is y prime is equals to, as I said earlier, we are solving for the product rule of this trigonometric function, and we're going to derive it. So we can say that we'll put this first, x squared, and we're gonna try to derive it. And the derivative, I'm gonna separate it. The derivative of cos is negative sine, and we will copy this sine x over 2, and we're going to derive this and what's inside, because we are talking about product rule and it is 1/2. After that, the second term. So what is the second term? The second term is this. So we're going to put a plus here, and the derivative of this is 2x. We're going to derivative this, because in this part we must stay it, because in the rule of the product rule, we must stay the first term, then derive the second term, then derive the first term, then second term again. So after that, we're going to copy this part, and it will be cos x over 2, and don't forget the parentheses. So we will make it more clarified or more clear in this, because we will multiply it, so it will result into y is equals to negative x squared sine x over 2, and as I said, we will multiply this over 2 plus, copy this, 2x cos x over 2. So that is the answer for our first problem. Okay, The answer is y prime is equals to negative x squared sine x over 2 plus 2x cos x over 2. Next in our list, in our problem, is we're gonna differentiate this problem by implicit. So this problem is involves with logarithmic. So I'm gonna flash the logarithmic function and derivative. So our given here is log x squared y is equals to 1/2 x ex plus ln y. So we know the equation and we gonna try to solve it in implicit differentiation with logarithmic function, the derivative of logarithmic function. So I will cut this video and I'm gonna flash the derivative of logarithmic function. Okay, let's proceed to solve this problem, and as I flash the derivative of logarithmic function, we know that this log will be 1 over x ln, and the derivative of this x squared will be 2x, and after that we're gonna derive this y and it will result into y prime, and this other half of the problem, the derivative of 1/2 x will result into 1/2, and the exponential part here is I'm gonna flush the exponential also. So let's focus and solve this problem. So as it said in the problem, or it is e over x, and it is, or it will stay. So we can copy this because the derivative of exponential e raised to x is still e raised to x. And next, plus ln y. So this problem involves with logarithmic function also, so it will result into y 1 over y, and we're gonna simplify it. So it will, our answer will be 1 over, no, sorry, 2x over x ln y prime is equals to 1/2 e raised to x plus 1 over y. And we're gonna make alone, or to make this a whole answer, we're gonna divide this by 2x over x ln, and divide this also by 2x ln. Wait, here, right? And after that, we'll cancel this. I'm gonna cancel that, and it will result into y prime is equals to 1 half e raised to x plus 1 over y all over 2x x over ln. And that's my answer, and that's how I solve this problem. And also, we have our last problem to end this session. So our last problem will be, wait, let me get another paper. So this is a new paper, and our last problem will be involves with hyperbolic function or the derivative of hyperbolic function. So before we start, I'm gonna flash it. So now that we've flashed the derivative of hyperbolic function, now we can proceed and try to solve this problem. So our problem is y is equals to hyperbolic sine, open parenthesis, e raised to x plus 4 hyperbolic cos or cosine, and this is it, and open parenthesis ln x, and that's our equation. And we're gonna try to solve this. So it involves, as I said earlier, that it involves with the derivative of hyperbolic function. So the derivative of y will be y prime, and it will equals, so the derivative of hyperbolic sine is hyperbolic cosine, so it will result into this hyperbolic cosine, and copy this equation, e raised to x, and we're going to derive this. So as I said that in the first problem or the earlier problem, the derivative of e raised to x in exponential function will stay. So we will copy this e raised to x plus, we will copy the 4 or bring down the 4. And the derivative of hyperbolic cosine is sine hyperbolic cosine. And we're gonna copy this ln x or ln, if am I right. So next is we're going to derive this, the derivative of this. So it will result into this 1 over x, because as I said, or as I flashed earlier, the function or the logarithmic the derivative of logarithmic function, and we're gonna simplify this. So it will result into this y prime is equals to, we will copy this, or we can put the e raised to x cos hyperbolic cosine or cos, as our professor said. Just kidding. And we'll copy this. It will result in, I'm sorry, e raised to x plus, we're gonna multiply it to this because it's single. 4 over x, and we'll copy this sine or hyperbolic sine ln ln I'm sorry, ln x, and that's my answer how I solve this problem. And we're gonna box it. So our final answer is e raised to x hyperbolic cosine e raised to x, open and close, plus 4 over x hyperbolic cosine ln x. So, and that's it. That's how I solve this problem. And thank you for watching. And that's it. Thank you.